We're doing 5 throws. N equals 5. Fair dice. Probability of success is a half. Probability of failure is also a half. Find a probability a tree will occur. Oh, sorry, a dice, not a coin. So it's 6, yeah. So a tree will occur as 1 in 6, and the probability of fail is 5 in 6. On no occasion. What does that mean? R value of 0. No successes. So it's going to be 5C0. Then it's going to be P, which is 1/6 to the power of 0. And it's going to be 5/6 to the power of what? Anybody? 5. Those two powers always have to add up. The two powers always have to add up to n. So the two yellow parts always add up to the n value. Okay, you throw that into your calculator, and you're going to get 3,125 over 7,776. Somebody verify that for me. 3,125 over 7,776. Is that okay? Once. So what are we changing the R value to this time? Change the R value to 1. And then we're going to do 5 choose 1. 1/6 to the power of 1. If that changes to 1, what does the other one have to change into? 4. 1 success and 4 fails. And oddly enough, that comes out to the exact same score. It comes out to 3,125 over 7,776. I'm interested to try that in my calculator. I'm dubious that they're the same score as each other. I think they actually are the same score. 5C1. Oh, sorry. Delete. C1. Multiply by 1/6. Multiply by 5/6. Put the 5/6 in brackets. And and power 4, yeah. What do we get? 3,000. Yeah, same answer. Grant. All right. Yeah, I think we get the gist, don't we? What's the answer for twice then? Twice, anybody? 5C. 2. 1/6 to the power of 5/6 to the power of 3. And it tells us all the ways we can get 2 successes and 3 fails. And that comes out to 625 divided by, I got 3,888, if anybody else gets the same answer. Perfect. All right. So 8 people, n is equal to A. You want 3 successes, R equals 3. So it's going to be 8, choose 3. That's how many different ways it can happen. You want 3 successes, so 3/5 to the power of 3. So P is 3/5. What's Q? 2/5, because if your success is 3/5, your failure is 2/5 to the power of 2, yeah? Or not to the power of 5. Why is it to the power of 5? Has to add up to A. Throw it all into the calculator and you get 0.123. Okay. Your P value is 7 out of 10. Your Q value is 3 out of 10. Your N value is 3 and your R value is 2. So 3 sync 2, 7/10 to the power of 2 and 3/10 to the power of 1. Did you get 441 over 1,000? Okay. And the last one. He will miss 3 puts in 4 attempts. So that means your R value is only 1 because you're only successful 1 time. And your N value is 4 attempts. And P and Q are still the same. So it should be 4. You only succeed once. 7/10 to the power of 1. 3/10 to the power of 3. Both of them have to add to 4. And you should get an answer of 1,029 over 2,500. Just checking out the different way of doing it. So I'm going to do 4 choose 1, yeah? 4C1, what's it? 7/10, yeah? 4C1 multiplied by, okay, and then multiply that by, to the power of. You got 189 over 2,500. And you got that the way you did it. So look, they're wrong and we're right. That's all I can say. Yeah. Yeah. So sorry guys, that was what did we say it was again? 189 over 2,500. I'm using the solutions to the book here just to go a bit faster, but sometimes they're wrong on occasion. P Q. Now, what I'm going to say is that N is 4. You have 4 children. R is 2 boys. Okay. Probability of having a boy is a half. Okay. And probability of the girl is a half. And then you just go 4 choose 2. Well, is it a half to the power of 2, and then a half to the power of 2. Okay, so that's for 2 boys. Okay. And what do we get there? Anybody get 3 over 8? Okay. Next one you're on is, so on the second question, it's gonna rub out what we did here. The n value is still 4, and because we're having all boys, the r value is 4. It's going to be 4 choose 4, a half to the power of 4, a half to the power of 0. Throw it in the calculator, and what do we get? Yeah. Now, believe it or not, I didn't get full marks for the first answer. Let me explain why. It's how many families. So out of 2,000 families, it's multiplied by 1 in 16 for the second answer, which is 125 families. What was my answer to the first question again? 3/8, and that's multiplied by 2,000, which gives me how many families? 750. So I actually didn't read this question exactly the way it should be done, so you have to be careful with that. Is that right? So whatever your probability is, you multiply by the 2,000 at the end. Okay. Who knows how to do at least one boy? What's the shortcut for that? At least one boy. What does at least one boy mean? 1 minus, so it's P1, sorry, it's P1 plus P2, isn't it? Probability of 1 boy plus the probability of 2 boys plus the probability of 3 boys plus the probability of 4 boys. Does that make sense? Now, I have a trick for you. Here's my trick. If I add in P0 over here, and I put a plus sign, what do they all have to add up to? They all have to add up to 1. Why did they have to add up to 1? That's all the probabilities. No boys, 1 boy, 2 boy, 3 boy, 4 boy. What happens if I bring P0 over the other side? So I could just do 1 minus P0 for my answer, can't I? And what's P0? We have it here. No boys is actually the same probability as no girls. So what can I do here? 1 take away 1 over 16, which is, yeah, it's 15 out of 16 families have at least 1 boy. And then what can I do then? Multiply that by 2,000. And our answer will be 1875.